This video is going to be a review of logs. So, I'll start off with the most basic question. What's a logarithm? It's an exponent. In other words, logs are exponents. Sorry, little joke on Toys R Us. So, here's what I mean by that. Generally, we have something that looks like this. And what this means is that A to the B is equal to X. So really what it is, a log is the inverse of this relationship. That's what it's trying to say. And what it does is focus on the exponent. So the way I think about this is A to the B equals X. So I use the recycling diagram there, a version of it to remember that. So, quick example, we'll do a couple of those. What this means is this. 2 to the 4 is equal to 16. So this looks at this relationship from the point of view of the exponent. Okay. So in other words, another way to think about it is that a log is an inverse of a power. So here's the power. Right here, here's the log. Okay. Another example. I'll use the next page. I want to find out what the natural log of 78 is. Well, first of all, why natural? There doesn't seem much natural about this, but let me show you what I mean. There is actually. So the log of 78, what that means, whenever you see that, it's really the log base E of whatever number is, 78. And remember, E is one of those mathematical constants. It's one of the most famous, perhaps the most famous after pi. And this is equal to 271828, 1828. And then it starts to go on and on, but it never repeats. So it's an irrational number. It's not a fraction. So again, a little bit of enrichment, you don't need to know that. And I can tell you in class how I know that. So you can win bar bets. Okay, so back to this number right here. Oh yeah, E is kind of the standard exponent. It's sort of like if you look at all measurements, at least in the US, we relate them back to feet or inches or pounds or whatever. Well, E is like that. E is the exponent standard. So often any exponential base will be related back to E. And I'll show you what I mean later about that. So back to the log of 78. Now, I'm not sure how this is going to show up on camera, but here's my TI. And hit the log button, hit 78, and I get this long string of numbers. So I'll even write them down for you. 4.356708827. Okay. So generally what we're going to do is we're going to round to 3 digits. I'm sorry, 3 decimals. So we're going to think of this when you have to write down a log for a problem or something. Just use 3 digits. Or 3 decimals, excuse me. So that's how we're going to think about this. Now that's just an approximation, of course, but I don't want you to write down all that. So, well, what does this mean? Well, this, first of all, the log of 78 is the log base E of 78, and this is equal to 4.3567 ... And what that means is that E to this number is going to be equal to 78. So we'll see how that works out. So, where's my E key? Right here. Second E, it's above the natural log, and I'm going to just copy that number, hopefully correctly. And I plug that in, and I get 78,002. So now the question is, why isn't that exact? It's because of rounding error, but let me show you something. I'm going to do E to the natural log, 78, close both parentheses. There you do get 78. So in other words, we're saying that E to the natural log of 78 is 78. Now, The calculator stores a lot more digits than what's on the screen. And you can actually change what it displays. I'm not going to go and do that. So that's why we get this discrepancy between this. Again, you can't really see this. I'm sorry. Between the fact that we get a 0.02 here and here we just get a 78. Again, this is hard to see. This is hard to see. So what I'm going to do is just point something out here. This almost looks like a cancellation. Now that's kind of illegal, but that's all right. That's the right idea. E and the natural log cancel, and we'll get to that in a minute. First, I want to go through some rules of logarithms. Okay, so talking about what a logarithm is, and I'm going to go over the basic log rules. Again, you've seen these, you know these, but I think it's worth a quick review of those. Again, if you don't think it's worth a quick review, feel free just to skip to the next video, or to later on in the video. So here's the first major log rule. We get the log, sorry, I want to use natural logs. That's what we're going to use in this course, always, the natural log. So when you multiply, the log of a times b is equal to the log a plus the log of b. And really what this is a restatement of this rule. E to the a times e to the b is equal to e to the a plus b. So that's all we're saying. Multiply bases, you add the exponents. So we have the same or similar rule for division, except this time we subtract. And what this is saying, that if you write e to the a over e to the b, well, that's the same as e to the a minus b. And there's several other rules. This is another important one. Natural log a to the r is equal to r natural log of a. And what this is really saying is this is a restatement of this rule. A power to a power, you multiply the exponents. Okay. Okay, hope that makes sense. So a couple more. We have the natural log of e. Well, just remember this is e to the natural log of e to the e, and that's equal to 1. And that's because e to the 1 is equal to e. And we have another rule. Natural log of 1 is 0. And that's because e to the 0 is equal to 1. So there's the e here, e to the 0 is equal to 1. I'll stick that little e in there. And those are the main rules. Now, want to look at a really important relationship right here. And it's this one right here. E to the natural log of a is a. We talked about that before when we did this example. It's a weird question. This is sort of the question, what is the name of the girl whose name is Mary? Well, it's Mary, of course. E to the log a is a. So it's asking you what do you raise e to get a? Well, it's the log of a. Okay. If that doesn't make sense, ignore it. So this is important, and the reason it's important is because that's where we get this log formula from. And I'll go through where this comes from. So basically, this is a lot like, in fact, it's the same rule. If you look at this, if you look at e to the u du, that's exactly what we get. We get e to the u over log e to the u, log e plus c, and that's equal to e to u plus c because log of e is 1. Okay, so this is really just a generalization for this. So for example, we'd have 5 to the x dx. Well, it's going to be 5 to the x, just like e to the x, but you divide by the log to compensate for the fact that it's not quite b. So, where does this come from? And that'll be the last thing I talk about. And I'm going to talk about that in the next video.